look at your MT9 LT6 seminar on applying trigonometry. The first thing I want you to do before we do the rest of the video is do the first 4 questions in your seminar and then come back and we'll go over the rest of it. What we're going to do in this video is we're going to solve real-world problems by using trig ratios and their inverses. And we're going to derive and use the formula for the area of a triangle by using trigonometry. We can't measure everything, so we'll use indirect measurement. Your GPS is an example of indirect measurement. They're not taking out a ruler and measuring the distance. They're looking at different things and areas to measure, and then they apply that to the actual problem. Whoops. Now, one of the things we're going to look at is angle of elevation and angle of depression. And you're going to find out they're almost the same thing. So if you're standing here, ooh, yay, look at that artistic. And you look straight out. That's your horizon. If you look up from the horizon, we're going to call that your angle of elevation. If you look down from the horizon, that's the angle of depression. So if we take a look here at Leo, he's flying his drone at the park. He spots a drone at an angle of elevation that he estimates to be 30 degrees. So elevation, he's looking up from the horizon, always from the horizontal line. That's the thing to remember, always from the horizontal line. The remote control can tell Leo that he's 102 feet above the ground. And if Leo is 6 feet tall, how far is he from the drone to the nearest foot? Well, we're not going to use the whole 102 feet on this triangle then, are we? So he's actually 96 feet above his eyes. The drone is, that is. Because we take 102 minus his 6 feet, that gives us 96 feet. Well, notice I've got a 30, 60, 90 triangle here. So my distance to the drone is going to be 2 times 96. Because it's a 30, 60, 90 triangle, the hypotenuse is 2 times your short leg. And my short leg is 96. So I take 2 times 96, we get 192. So I'd say Leo is 192 feet from the drone. Let's take a look at our next example. And in our next example, we have this unique hotel. Cottonwood, Idaho's Dog Bark is a popular tourist attraction featuring a hotel that's in the shape of wood-carved beagle. Pedro looks out the window 30 feet from the ground and spots a fire hydrant on the ground at an estimated angle of depression of 40 degrees. We want to find the horizontal distance from Pedro to the hydrant to the nearest foot. So we've got this picture. Now notice my angle of depression is from the horizon. So since it's from the horizon, that's not part of the triangle, is it? I could do it a couple different ways, but I think what I'm going to do is I'm going to look at it here. And let me make this thinner here before I start. And my angle of depression, I've got alternate interior angles. So my angle of depression makes 40 degrees inside the triangle with my horizontal line. Whenever you model angle of elevation, angle of depression, notice that's kind of like the angle of elevation from the fire hydrant to the beagle. So whenever you model angle of elevation, angle of depression with a right triangle, you model it with the horizontal line. Now, we know 30 feet is opposite. Oops, need my marker there. 30 feet is opposite, and I'm looking for the adjacent, which I'll call x. So that's going to be tangent. So we're going to say the tangent of 40 degrees not 400, equals the opposite, which is 30, over x. And I want to solve for x, so I don't like x in the denominator, so I'm going to take the reciprocal of both sides. I'm going to say 1 over the tangent of 40 equals x over 30. Then to solve for x, I'll multiply both sides by 30. So really, my exact answer is 30 divided by the tangent of 40. And then I'm going to type in my calculator. "30 divided by tan 40. And I get 35.7, so we'll say 36 feet. So I'd say the fire hydrant is about 36 feet horizontally from Pedro.